Okay, this one is just kind of a fun problem with factory. We have two rectangles. The area of the smaller rectangle, pretend these are connected and perfectly even in things, but the area of the smaller rectangle is 9xy squared. The area of the bigger rectangle is 12x squared y cubed. And we need to know what is the area, or sorry, what are the different dimensions of the sides. So go ahead and try this and then watch the video, see if you had the same idea and see if you come up with the same answer. So what we have to start with, because I could factor, like, figuring out the two dimensions, it almost looks like a square. It's actually a rectangle. For this first one, for the 9xy squared, there's a couple different ways I could do it. And the 12x squared y cubed, again, a couple different ways I could do it. To find the area, remember it's length times width. But if I want to find the area of the whole rectangle, we would first have to add these things together, right? So I'm going to add my two rectangles together. 9, I'm going to start by using the pen instead of the eraser. 9x squared y, no. 9xy squared plus 12x squared y cubed. And the variables attached are both x's and y's, but they have different exponents. They're to a different degree, and so we can't put them together. We can't simplify this any. So we're stuck with the 9xy squared plus 12x squared y cubed. How does that help us? Well, all we really know right now is the area of the whole rectangle is 9xy squared plus 12x squared y cubed. But let's factor this. So I have a 9 and a 12, and my factors for 9 are 3 and 3 and 9 and 1. So I'm betting that it's the 3. 12 is divisible by 3 times 4, so we're going to take out a 3. We have an x and an x squared. So x is our lowest power, or our lowest degree, so we can take that out. And we have a y squared and a y cubed. Y squared is our lowest degree, so we can take that out. So we have 3xy, not cubed, 3xy squared. And then in parentheses, 3xy squared times what is 9? Times what is 9xy squared? That's times 3. That would give us 9xy squared. And then 3xy squared times what gives us 12x squared y cubed? Well, 3 times 4 gives us the 12. X times x gives us the x squared. And y times y squared gives us the y cubed, right? And so we have these two dimensions. So what do we know about that? Well, there's only a couple of different ways that would work for this. Let's try, well, the one that makes sense, or the one that seems to work best, let's try this one. Let's say that, because remember, this is length times width, so this times this equals the area, right? And we know that length times width equals the area. So let's say that this entire side is 3 plus 4xy, and that would make this side 3xy squared. And see if that makes sense. 3, okay, sorry, I skipped a step. If this entire side is 3 plus 4xy, and this side is 3xy squared, what do we have to do to get from 3xy squared to 9xy squared? We would have to multiply it by 3. And so this first question mark right here would have to be 3. And then if that one's 3, this one is 3 plus 4xy minus the 3 gives us 4xy. And then if we keep going around, this side over on the right is the same, 3xy squared. This would be 4xy, and this one would be 3. And let's see if that works. So 3 times 3xy squared gives us the 9xy squared. So that one works. 4xy times 3xy squared would give us 12x squared y cubed. So that one works. And so that's what the division would be. Is there any other way that you can think of, or is there any other way that would make sense for this setup? Let's just look at a couple. I think that that's probably the only answer that really makes sense, but let's just look at a couple of other options. Let's say, trying to get rid of the green without erasing too much else. Okay, let's say that, okay, we know that our factors are 3xy squared and 3 plus 4xy, but let's say that we decided that this upper side, the top side, was 3xy squared. That would mean that the side would have to be 3 plus 4xy. And then we would have to figure out how do we get the 9xy squared using a 3 plus 4xy. And it doesn't really work. So that one's not really a valid option. The other thing that we could try is to keep the 3 plus 4xy, but say, well, this must be 4xy right here. So that's 4xy, and this would be 3. But then if you put the 3xy squared and you multiply that, you don't get the 9xy squared that we need. So that one doesn't work. So really the only viable option is to have this side be a 3, this side to be a 4xy, and this side to be our 3xy squared. And then, of course, this would also be 3xy squared because they're rectangles. Okay, so I'll leave it at that. The bonus material for this one is just going to be what is the perimeter of each rectangle individually and then of the total rectangle. And I'm going to do that really quickly. We would have, for the smaller rectangle, we would have the perimeter would be 6 plus 6xy squared. The perimeter of the bigger rectangle would just be 3xy squared plus 4. Sorry. My pen is not. Would be 6xy squared plus 8xy. Remember 4xy and 4xy, 3xy squared plus 3xy squared. So 6xy squared plus 8xy. And you might be tempted to say, okay, well, the perimeter of the whole thing is we just add the two together, except that the perimeter of the smaller rectangle includes this side right here, and the perimeter of the whole rectangle does not. And so what we'd end up with is our 3 plus 4xy times 2 is 8xy plus 6 plus 6xy squared. And we could actually factor that out, maybe. We do have a common factor of 3, but we don't have x's and y's and everything. But if we were to put this in standard form, it would be 6xy squared plus 8xy plus 6. That would be the full perimeter of the entire thing. Okay, that's it.